Good morning to all present here to attend in the AICT Adult Academy sponsored 5 days online faculty development program on the topic IoT for wearable devices from 11th to 15th January 2021, organized by the Electronics Department of St. Kitts College of Engineering. This is the first online FTP sponsored by AICT Training and Learning Academy, conducted by the Department of Electronics Engineering. This program aims at providing an opportunity for participants to enrich their knowledge and skills in developing various solutions for solving engineering problems in the society. This online FTP serves as a platform for research scholars, faculties, engineers, and students to relate on cutting-edge technologies in IoT. The course contents are Introduction to IoT, Wearable Antennas, Wearable Sensors, Introduction to Wearable IoT, Setting up Wearable IoT from Scratch, Introduction to Node MCU, Wearable IoT Hands-on using Node MCU, IoT Product Development for Wearable Applications, Serverless IoT Architectures for Wearable Computing. This FDP will be conducted from 11th to 15th January 2021 with 3 sessions on each day. The honorable speakers of today's sessions are Dr. Shajulin Benedict, Assistant Professor, IIIT Kottayam, who will be the speaker on the topic Serverless IoT Architectures for Wearable Computing. Dr. Sridevi Kemenan, Associate Professor, Amrita School of Engineering, Amritapuri, who will be the speaker on the topic Introduction to Wearable Antennas. Dr. T. Shanmuganandam, Professor, Pondicherry Central University, who will be the speaker on the topic Wearable and Implantable Antennas for IoT. General instructions to the attendees are, please mute your mic and turn off your camera during the session. Please fill the feedback form shared after each session. There will be a separate question answer session. Participants can turn on their mic to ask your queries at that time. Kindly join 5 minutes prior to the sessions. Instructions on the final test and issuance of certificates are, a test shall be conducted by the coordinator at the end of the program, as the certificate shall be issued to those participants who have attended the program with minimum 80% of attendance and scored minimum 60% of marks in the test. This is the 7th session of the online FTP on the topic Serverless IoT Architectures for Wearable Computing. The speaker for this session is Dr. Shajulin Benedict, Assistant Professor, Indian Institute of Information Technology, Kottayam. I take this occasion to welcome everyone to this session and thank you all for being here to attend the very same. Before moving on to the session, I invite Ms. Chinju Ezragam Maliga to introduce the guest speaker. Over to you, Chinju.
Thank you, Chippy. Am I audible?
Yes, you're audible.
Good morning to everyone. I welcome each and everyone to the third day of AICT adult-sponsored 5 days online FTP on IoT for wearable devices. Today, we have Dr. Shajulin Benedict to handle today's first session on serverless IoT architectures for wearable computing. So let me introduce our guest speaker. Dr. Shajulin Benedict is currently an assistant professor at Indian Institute of Information Technology, Kottayam. He has done his bachelor degree with distinction in Electronics and Communication Engineering from Manonmaniam Sundaranar University, Tirunelveli. He received ME degree with a university second rank in Digital Communication and Computer Networking from AKCE Anna University, Chennai. He did his PhD degree in the area of grid scheduling under Anna University, Chennai. After his PhD, he joined a research team in Germany to pursue postdoctorate. He served as professor at Essex CCE Research Center of Anna University, Chennai. Later, he visited TUM Germany for teaching cloud computing as a guest professor. His research interest includes grid scheduling, cloud computing, performance analysis of parallel applications including exascale, etc. So on behalf of St. Kitts, I welcome Dr. Shajulin Benedict, Assistant Professor, IIIT Kottayam, to the 5 days online FDP on IoT for wearable devices sponsored by AICT Adult to speak on the topic Serverless IoT Architectures for Wearable Computing. Over to you, sir.
Yeah. Very good morning to one and all. And also let me thank the organizers for hosting me here. Um, Welcome the participants for this session for another 1.5 hours, where we will be discussing about serverless IoT architectures for wearable computing. Yes, short introduction was already given by the faculty of Saint Gates. Yes, currently I am also having few funded projects, and I have also completed few funded projects in line with also in line with IoT. Um, uh, Let us begin the session. Basically, in this session, I will be handling the topics like IoT with more emphasis towards wearable computing. And then I will be focusing more on the architectures, especially the serverless IoT architecture, which fits very well with wearable computing environments. And I will take you towards monitoring such kind of serverless IoT applications and what kind of tools are available for measuring such serverless architectures or serverless IoT applications. Yeah, this is the flow of the presentation for today. Yes, you all are well familiar with IoT, but still it is my duty to again give some insights on IoT. Of course, IoT is very, very popular, and it's called Internet of Things because it is an extension of Internet to Things. That's the real meaning of Internet of Things. So things you mean like not only computing devices. Earlier, traditionally we all know the internet was offered to mobile devices like smartphones, or the internet was provided to computing machines or servers. But now we are extending the internet to things. Things in the sense it could be our bench, it could be desk, it could be fan, it could be any kind of objects that could be identifiable, and we are trying to extend the internet to such kind of things. And therefore, it is expected that the future internet would consist of trillions of sensors or digitized objects which will be identifiable with unique IP addresses. And billions of personal devices or things will be connected together. And in addition, the normal computing devices, like millions of computing devices, will be having this internet. So the future internet is going to be very, very competitive enough where billions of personal devices, where billions of wearable devices, your assistants are going to help in such a way that you attain what kind of knowledge that you want to attain from the environments. So that's the reason the entrepreneurs, business people, as well as technical aspirants are driving, or they're moving forward to identify some new problems, get solutions based on that. And the future internet therefore enables a very smarter society in the near future. And it is like I was watching a fiction, like saying in 2050, most of the developments, most of the communications, things are going to happen through robots, right? So robots will guide people through the wearables that they have. One very good example that I would like to point out here is like a smart helmet, right? In 2050s, there are possibilities that you could wear such kind of helmet, and this particular helmet will be capable enough to get the information from your brain, and you can also feed the information back to your brain, right? So of course we all forget many things, right? Starting from the small age, right? We have been visiting several places, tourism places. We have been getting connected with many lovable people, and lots of memories are there. which sometimes gets fades. Most of the time it gets fade because of other information that enters into our brain. So if there are such kind of wearables, if you are having such kind of helmet which could get the information, collect the information to the chip, and again, if you want to feed that chip and see or feel what happens in the future, in the past, and how to move or take your ideas back to the orienting towards what you want to do or what you want to achieve, is definitely going to be a remarkable thing in the future, right? So such kind of wearable devices is going to change the world in 2050s. Lots of innovations, lots of products, lots of ideas are popping up in this similar field. It also enables, the future internet also enables a very knowledge-driven society. That means, let us assume that you have some wearable gadgets like wristwatch you wear, and all smart city citizens are wearing such kind of wristwatch. And this wristwatch is going to get the information, collect the information, and guide you properly, such that you are getting the knowledge of the society. Knowledge about the society is very, very important, because you get an information what to do and how to do, and how to prevent yourself and how to protect yourself, also how to protect your family, right? So knowledge-driven society will be enabled in a short span of time because of this future internet. Very good examples, like you want to wear such wrist watches, and it will just highlight when you reach some sort of shopping mall, saying that, oh, you wanted to purchase milk, or you want to purchase some particular bench or desk. Okay, this particular thing is available very next to the next to you. The mall is somewhere near, and these are the competitive prices. So it has to show you some sort of strategy of values, saying that the price in this particular, or for a price in shopping mall 1 is this much, the price in shopping mall 2 is this much, and you are very next to that shopping mall, that so that you can purchase it now. And it also should show or highlight the amount that is available in your bank, and how much budget you will have, and what kind of planning you could do, and everything. These are all some sort of information that we want, and all this knowledge-driven society is possible. The knowledge-driven society is possible using such kind of IoT devices. Similarly, cognition-enabled machines and expert systems will become a common solution, right? Like machines, robots, not only robots, machines. Hereafter, you will notice like machine will communicate to the other machine. It is not like a human is communicating to human, but a machine will communicate to the other machine. Like for example, the fridge or the washing machine will communicate to the gadget that is available with you, like the smartphone. It will communicate to your smartphone, saying that please send start doing this kind of activity, start being productive, right? Many times there are not possible solutions to have productivity in the society, right? So even most of us, right, we attempt to do something. We try to be productive. We try to produce a lot of articles. We try to produce a lot of publications, or we try to create a lot of products. But in most of the time, the productivity of individual is lost, because we are not guided properly. Earlier guru system was not there, but that guru system is not very effective these days, because they are not continually monitoring. The system is not continually monitoring the productivity of the human being. Right now, if robots, if some wearable gadgets assisted with some sort of analytics is doing that, definitely it is going to keep the manpower more productive. Right? This means the wearable devices jointly with the devices from home offices, motels, coffee houses, airport, gyms, hospital, everywhere. They all need to connect each other and they have to give some idea. It has to collaborate, it has to give some information, and it has to suggest the future activity, what it has to do. Right? It's very clear, therefore, that IoT means it is an extension of internet where the network of physical objects that contain embedded technology to communicate and sense interact with their internal states of the external or the external environment will happen, right? So these are few definitions which clearly points out that it's an extension of internet to some devices, some things, some not only computing devices. Surely, there are a number of possibilities that you could do, and the trends in IoT, trends of IoT in India especially is very, very tremendous, right? I will explain to you where this wearable IoT comes, but in broad sense, IoT in India is having a very broad scope. And you, as you could see, comparing a lot of other technologies, including artificial intelligence, blockchain, or data science, or whatever, IoT is having around 200% of growth rate because it also combines a lot of other technologies together. And here, as you can see in the right side, like comparing India, the USA, and the other countries, Western Europe, and so on, the market that was launched, the billion euros that were, the $1 billion that were no, projected to for the growth of IoT is high, tremendously high in India. The reason why, because there is a possibility, there is a hope that such society, such developing country require lots of developments that that has a lot of problems, and those problems could be identified and it could be addressed with the help of such IoT devices. So seeing the different sector where IoT is becoming more popular is like agriculture, retail, healthcare, automotive, transport, logistics, manufacturing, and so forth, and utilities. See here, you can see like around 25% of the growth is with utility, right? So this means like personal gadgets, it could be some sort of small devices which help you for providing assistances, right? Like voice assistant or video assistant or whatever assistance that it can offer. It has around 25% of growth base, right? And similarly, if you see wearable computing technologies or wearable assisted technologies in the market, you could notice like around most of the applications are fitting with healthcare and personal care. So not only that, it also fits very well with the transport industries. It also fit very well with the automotive industries. How it will be providing support to healthcare, there are n number of examples, like you get patient monitoring, you get patient assistance or preventive support through healthcare systems, right? That means you can have some sort of wearable devices that will be able to project, that will be able to show how your health is behaving at the moment. In automobile industry too, it is very, very useful because some wearable devices guide the transportation, some wearable devices guide the tourism of the particular person. Some wearable devices are capable to get the atmosphere, the weather prediction. It also assists based on the weather conditions, that where you have to move and how you have to move and so on. Transportation and logistics systems also can use wearable devices. So in short, in a broader perspective, IoT in Indian market has seen a very hitting trend, and that's the reason you could see like major funding agencies, including the earlier Planning Commission, which is now like Nidhi Aayog, which is also focusing on developing all sort of such products. IoT-based products. And if you could provide a lot of such products, that definitely will help the society in general. And you could see like the global scenario. So far, I have discussed the trend that is there in India, but if you see the global trend, it's also very, very high that smart city is growing like 23% compared to connected industry, connected car, and smart energy, and so on. Smart city, why? Because people are involved in that, right? People want to get more revenue. What is the difference between a normal city and a smart city? What is the difference between a rural and city is very clear to us, right? Because we have visited cities, and we have also have, most of us would have also come from some rural places where we know there are not many facilities and so on, right? Cities, definitely they have a lot of support, infrastructures. Infrastructures are good, the assistance is good. But what is the difference between a normal city and a smart city? In smart city, you have additional few more things. That is, you have to get some assistive, some information. You have to get some knowledge such that the revenue of whoever is living in the smart city should be comparatively very high than people who live in cities. This means they will have almost all infrastructures that are there in the cities, right? In addition, the comfort of the people who live in smart cities are very, very high. This means, they get the information from lots of IoT devices. Here plays the major role of wearable IoTs, right? So you should get some assistance, you should get some notification, you should get some information like where the job is available, how you will get, what kind of product you want to develop, what kind of assistance you have to offer to the society so that your revenue will be increased. So that information should be available for smart citizens who are living in smart cities, right? So you could see, therefore, the trend is continually growing for smart city, which includes wearable systems, right? There are certain platforms accordingly developed by several companies. Most of the cloud-based companies have started offering the IoT support, right? For example, Amazon, they have very tremendous support for cloud services. They were offering IaaS, that is infrastructure as a service, platform as a service, and software as a service for people, for providing infrastructures, cloud infrastructures, computing infrastructures, and so on, right? Now, not now, but immediately after they start serving as infrastructures, they also started to offer IoT, right? That means the wearable devices could be connected to Amazon. The wearable devices could be connected to Google. It could be connected to Azure, right? So most of the cloud platforms, the leading cloud platforms, they started to provide support to IoT, and this becomes like a business model, right? Because when leading industries start playing the role, definitely the growth of that particular technology becomes become multitude growth, right? So likewise, you can notice that most of the top leading platforms that are offered in IoT are coming from such cloud players. And you could see around 29% is coming from Microsoft Azure, then Google Cloud IoT, then Amazon, which also now has Greengrass technology, which is very, very impressive one. Then Cisco, Watson, and so on, so on, so on. These are a few set of platforms where IoT devices, including wearable technologies, could be used. So, having seen the importance of IoT, the wearable IoT, and how it reached the market, how it creates a kind of traction in the market by providing wearables. Now we are in a situation to understand what are the different subdomains that comes under this IoT, and where is this wearable IoT fitting in, right? So if you see the subsets of IoT, right, there are five major categories. One is industrial IoT, second one is consumer IoT, social IoT, then semantic IoT, and productization IoT. We will be focusing more on this consumer IoT because the topic becomes wearable IoT. But you can understand wearable IoTs are most predominantly applied in smart cities and in some healthcare sector as well as transportation sector. These are the three major sectors where the wearable IoT fits very well, right? So broadly, if you're speaking, IoT could be classified like this. And let me give you some information, some hints on what industrial IoT mean and so on. So industrial IoT is mostly focusing on machines, right? So automating machines, automating the industrial processes, right? So this means it applies embedded intelligence and network connectivity of IoT devices to improve the systems as well as the product development, right? It introduces smart design principles for developing products. Most of the time, this industrial IoT are data-driven or event-driven. Several companies have already adopted the industrial IoT, like car manufacturing, 3D printing industries, energy industry, healthcare industry, manufacturing sector, and smart buildings have already developed this IoT. What happens in car manufacturing, basically, you can imagine like there are plants, right? Car manufacturing plants, they may be scattered here and there in several geographical locations. Earlier, traditionally, if you see, car manufacturing was done in one particular location, only in one particular location. But now, with the concept of cloud manufacturing concept, the production units can be spread across different places, different locations. That means one can be located in Kerala, one can be located in some other state, and somewhere. And they are all scheduled properly such that the jobs for manufacturing is done perfectly without much human intervention. So how it can be done without much human intervention? It could happen because of sensors, right? So a plant in one particular location will have very good detailed information about how many employees are there, because they could wear some wearables, and how the person is working there, whether they are productive, and how many car manufacturing part is complete. And once when it is complete, immediately the sensor will send the information to the next plant. So one location, when it is complete, it is sending the information to the next manufacturing unit, and the next manufacturing unit could start doing the process. Or it can even start to prepare the ground for that particular plant, right? So Industry 4.0 is a sort of a revolutionary system, a revolutionary thing, which basically induces or it promotes automation, right? This means that we are not losing jobs, but we are modernizing systems such that the people who are there can develop newer products in the future, right? Industry 4.0 is based on Germany actually, but the same term, it is defined as industrial internet in the USA, right? Why? Because why it is called Industry 4.0? Because it is named based on the revolution that it has, right? Fourth industrial revolution. Compared to the previous revolutions, like initially it was water and steam power engine based, which created some sort of revolution for industry. Then electrical engines and power using such electrical engines and power for automating or rolling the wheels and so on in the industries. This created the next level of revolution. Then the third revolution created in terms of electronics and IT, right? Some small, like providing IT support, some programmable controllers and so on were used for automating. Many semi-automation was done in the mid 19th century, which was considered as the third revolution in the industry. And now it is Industry 4.0, which is which enables the production, the mass production, automatizing most of the developments with the help of machine-to-machine communications, right? The machine, not only from the attached gadgets, but also the machines that are available with the workers, the machines that are available with the people involved in the farm, and so on, right? So all these information are collected together, and the gist of that, the synopsis of that is judging automatically with the help of some analytics, right? So Industry 4.0 is definitely a sort of revolution, a sort of development that has changed the way how the industry performs. How it evolved, or what kind of steps that they have done earlier was because the manufacturers were finding difficulty to do real things, to do some sort of collaboration. They were finding difficulty to identify the best product. They were finding difficult to identify where the available raw material is located, and so on. So this information are assisted with the information that are collected, cognitively collected from different sources, from different places, and that information is finally delivered as in the form of Industry 4.0, right? Siemens plays a major role in this Industry 4.0 industrial IoT, where they already collected the opinions from over 40 manufacturers around 11 countries to understand what is the real requirement for such manufacturing system, right? So they have identified like specialized digital skills are required, access to finance for the scale of business is required. See, normal industrial system is not having such kind of automated access to finance, right? So if some gadgets, right, like the gadgets that are using for personal authentication purposes, like fingerprints and so on, if they are used automatically to scale the or get connected to the businesses, then the industry, the Industry 4.0 concept becomes much faster, right? That means the machine will decide by its own, based on the information and based on the policies that are fed to the system, to purchase something, to order something, right? To order the raw material from some other plant, right? From other industrial shop, right? So these are the things that that creates, or that are really required by the manufacturers, right? So the data, of course, is going to be going to explode. It was told that Amazon was saying like per day they are getting around terabits of data for processing this IoT devices, right? So there is possibility like the data could explode. This is just with one provider. Similarly, you can imagine Google provider will have similar issues of large data. The other Microsoft will also have similar issues of getting such data, right? Google as well as Facebook and all the social medias are now collecting lots of data, and all this data can also get assisted, can also get information from videos. For example, even Zoom is now collecting the video and these video or no information are stored somewhere, and the analytics is happening, and finally in another 10 to 15 years, they will come up with some case study saying, okay, the presentation should look like this and it should not look like this, right? So all this novelty could happen because of the personal assisted gadgets that are connected with the system, right? So Industry 4.0, which comes under the category of industrial IoT, is definitely playing a major role. Some other good examples that comes under this category is predictive maintenance, right? For example, your your connected information, your connected sensors will start providing information to the manufacturer. For example, let us say there is a car that you want to do some maintenance, right? Normally, you doesn't know whether the tire is already, almost flattened, or whether some sort of oil change is required or not, right? Um, if the tire is not available at your home country, like for example, if you are having a let's say you are having a BMW car or some Rolls-Royce car. Of course, it may not happen for the moment with us, but no, I just wanted to point out like such kind of cars are available with you, and now the workshop may be located somewhere in very far locations. If you are not, you are giving, you just get an information at the last minute, right? The tire is almost flattened, you want to replace that, right? So then you have to go to the workshop, you have to inform them, and that particular person may have to order this particular part, and no, it has to come from some particular country where the manufacturing happens, and then it has to manpower should be done for doing this maintenance. So this is basically very very tiresome job which could eat your time. It could take at least 20 25 days, which is ridiculous in the sense in the modern world, right? So if you want to, if you use some sort of IoT sensors there, right, you can definitely do all these things automatically. Like for example, your tire, maybe there should be a sensor, a small device that checks whether your tire has to be replaced or not, right? And it has to inform accurately just 30 days prior to what you want to replace. It has to inform the company, and it has to provide to your wearable or your smartphone devices, personal assistant devices, that yeah, now you have such kind of competitive companies which could offer the price for that particular tire. In one shop it could be 5,000 or 20,000. In one shop it is around 30,000. Where should I order? And it can also be automated, of course. Like you can have some sort of soft boards which can act on behalf of you based on understanding the behavior characteristics as well as the historical purchase that you have done, and based on the bank balance that you have. So based on all these informations, it can decide by its own, and it can choose one, so that the purchase is done and it is giving to you the tires on time, and therefore you could save time. You could be a productive citizen forever, right? So this is the idea of keeping these devices. So customers are getting in affordable price. Industries are getting mass production. They could do mass production because they are getting the prior information how much they want to produce, right? So if they are collecting such information from 100 countries, and they now have sufficient number for them to do a mass production, and thus the price of the production becomes cheaper. So all are benefited. That's the idea what I want to point out here, because of machine-to-machine communications that's happening, right? Thus, in the future, the product's life cycle will become much smaller while comparing the day of the day that is happening today, right? So lots of businesses, small scale industries as well as large scale industries, all will get benefited, and especially with small scale industries, if someone wants to start a new company and if they are having such ideas, definitely this industry 4.0 with the help of devices, it will be very, very helpful, right? There are several building blocks for such industry 4.0, big data, autonomous robots, simulation, horizontal vertical integration, IoT, cybersecurity, cloud computing, additive manufacturing, augmented reality. All these are certain techniques that are associated with this. I am not going to go in detail with all these things, but just remember, these are all coming under the subset of industrial IoT. The second subdivision of IoT is consumer IoT, which refers to personal physical devices, right? Here, several devices, mostly the devices that are wearables, right? Industry also has, industrial IoT also uses wearable devices. Like as I have told, if the laborers are using their wearable devices, the health check of the person who is working there could be perfectly audited, right? The productivity of that particular labor could be checked. All these things can be done in industrial IoT too, right? Although machine is communicating to machine is the major factor in industrial IoT, consumer IoT is fully specializing for wearables, right? Wearables, gadgets that are mainly focusing on the personal assistance, right? It is like commodity devices that are quite popularly available, and that should be used for the normal cases, right? And it should follow the normal health issues of whatever radiations that it emit, and that and all that should be as per the IEEE standards that the devices should follow, right? So devices such as wearable devices, gadgets, fashion items, portables, implantables, handhelds, consoles, appliances, instruments, voice assistants, and utensils. These are all some of the examples or some of the devices that comes under this consumer IoT. Wearables, I have already told, like rings, recently, ORII is a company which has produced voice assistant. You could just put a ring, wear a ring, and you can just keep your fingers on the ears, and you can start speaking. You can protect people, the loud signals that are coming from outside. They say they bring this technology just to enable a newer transformation in terms of voice assistance, especially for translating the sentences, translating the voice. Like for example, someone in the meeting speaks in some other language, and he can use the ring, and he can put the finger on his ears, and it will just explain to him in the speaking in the native language. Of course, it is still on research level product, but the ideas and the things are already out, right? Utensils like wallets. Nowadays, people always have wallets, but they are not identifiable ones, right? But in recent years, you could see the wallets with RFID. These wallets will send information about where this wallet is located. It even says how much amount is available inside the wallet, and it will keep track of the currency notes that are there in the wallet, and it just provide information to sync the devices that are assisting you, right? So all these type of devices are coming under consumer IoT, right? There are challenges like how to bind several heterogeneous devices and so on. Of course, there are several applications. Of course, you would have also come across some of those applications in the rest of the lectures, but I just want to point out like a few applications like prevention of diseases, to check hypertension or blood pressure, to check the status of stress pattern of children, uh, then to suggest a medical decision, to provide weight control, and so on, so on. So there are n number of applications in this wearable devices category, right? The wearable IoT category, right? Especially, diabetic patients, if they are sleeping, they don't know whether they reached 40 sugar level or they are normal. So if they are 40 degree, I mean not 40 degree, 40 sugar level, then or less than that, right? Um, Only some sort of personal assistance cameras or something could be in a position to identify that, right? With the sweating or the texture differences in the skin and so on, with that only you can identify that. Or someone should be always with them to identify, especially when they are in sleep, right? So these kind of personal assistant devices will definitely help the healthcare, health monitoring of people. Similarly, suggesting physical exercises, like which exercise fits very well because you already have some injury and you don't know which one you want to choose, right? For that, it is helpful. Similarly, physical activity monitoring, like recently they released a textile, a fabric T-shirt, which you can wear from that is from a company called Polar Zeal. This particular company has provided the textile the shirt, T-shirt, which you can wear and you can set some temperature. So it is just monitoring the temperature of the body as well as outside, and it based on the difference, it attempts to heat up the textile. So such that it provides required heat when you move in the cold regions. Of course, it is not much beneficial for us in this Kerala region, but it will definitely it will be useful who are living in the cold regions, especially in Jammu and Kashmir or some other parts of country. So it improves the quality of patient monitoring, right? So you can imagine like several applications that comes under this category of wearable IoT. You can use it in shoes, eyeglasses, earrings, clothing, gloves, watches, right? Skin attachable devices. And all these devices, which follows, most of them are following that IEEE 802.15.4 protocol standard, so that it has very short range communications, and they are communicating to smartphone or some compute capable devices. So industrial IoT, then consumer IoT, and the third, fourth, and fifth are social, semantic, as well as production IoT. I'm just going to give a very short explanation on this. So social IoT, it addresses the establishment of social relationship among interacting objects. Like for example, you have a Facebook, Google, LinkedIn, and so on, and you don't know which friend will help you much, right? Social IoT should be in a position to do that. That's the subdivision coming under this IoT, which tries to do all sort of sentimental analysis or whatever it has to do, and it has to provide the required information, like who you have to talk to and who you should not talk to. Right, politicians will be very, very eager to check this because they wanted to. They really wanted to know what is who are which subset of people are more eager to support them and who they should not support, right? That kind of information will be guided here. So likes, dislikes, updates, and interactions from the information it has to sense and it has to provide. That is called semantic IoT. whereas social IoT, and whereas semantic IoT, it is more towards providing the tailor-made solutions. Like it is more conceptualized or personalized to some particular topic, especially like you give some semantics to get the information of what it has to do, and it has to provide that. Production IoT is the last category where this particular IoT is preferably be looking for providing a new product based on the sensory informations. Right, it is mostly useful for like prototyping and stuff like that, or also with 3D printing, based on the mentality, based on the sensory information from the people, from the person who produced something. From that sensory information, it has to bring some customized application, customized design, or it has to bring some customized product, which should be developed, or it has to be prototyped by 3D printers. So these are several classifications of IoT, where we have seen that the consumer IoT, which is more focusing on the product, the wearable devices, right? So far we have seen the three categories, as shown in the agenda. Now we are moving towards the architectures, the serverless IoT architecture, which will be helpful for the wearable IoT or wearable applications, right? So before that, I will just give a broad perspective of IoT, and then I will move focus towards serverless IoT, right? Generally speaking, IoT architecture consists of three building blocks. Okay, if you take any kind of IoT application, typically you will have sensors, actuators, and then the network, right? Broadly speaking. So generally you are having like that, like sensors, it is going to measure some sensory information like temperature, lighting condition, or the pressure and so on. So that kind of sensors, that is one component. Then you have actuator, which is going to do some actions like sending emails, maybe one actuator, right? It's an action, right? Or it is going to move some, it is going to do some mechanical motion, right? Then that is also an actuation. So you have sensors, you have actuators. In between, there are some networked devices which is going to do some sort of analytics. It is going to do some sort of evaluation from the data, and so on, so on. And typically these networked devices or connected devices, typically distributed ones, and mostly cloud ones, right? So here I am showing you a very broad generic wearable computing architecture. You could see like you can have n number of wearables, like group of wearable devices. They are connected to mobile devices because you want to have some sort of analysis there, and then from mobile devices it goes to cloud environment, where of course the users, the clients, they can just log into such services, and they can see what's happening on for particular application, for a particular IoT application, right? For example, health monitoring or patient monitoring, or monitoring the temperature of your textile device that you wear. So all these things follow the same principle, that is sensor, actuator, as well as network devices. So here, wearables, typically they are sensors and the actuators. There can be actuators also, because for example, as I have told, a textile, the dress that you wear can have sensors as well as actuators. In that example, what I have mentioned, sensor could be the temperature sensor that is going to sense the temperature of your body as well as the temperature of the outside world, right? The environment. Then actuator, what is actuator? There can be some actuators which is going to heat up the heating device, which will provide sufficient or required temperature for your shirt, for your body, right? So that's actuator. So you have sensors, you have actuators as wearable devices, right? And then you have networked devices. They are different category of networked devices. Like I will talk about what is edge, fog, and cloud. But now you can see like you have mobile devices and the cloud environments for doing that kind of networking. So as I have explained, the sensors um, typically kind of device which is going to detect and measure some physical property, right? So it can be small, it can be large, it can have different properties. It can measure chemical property, it can measure mechanical property, it can measure electrical or electronic and so on, right? Then sensors, there are several features like they are provide measurable measurable values, right? They don't measure multiple properties at the same time. They do not influence what was measured already. Of course, there are several sensors: light sensor, touch sensor, humidity sensor, temperature sensor, force sensor, water flow sensor, position sensor, speed sensor, soil moisture sensor, and so on, so on, so on. Several sensors are available. But most of the sensors that are more focusing towards wearable devices or something like this, that is the sensors that are most commonly applied in wearable IoT or wearable computing applications are something like this. That is accelerometer, which typically shows you like how much force you have exerted, right? That kind of information, like how speed it is moving and or something. So your wearable, you have kept some device, and that device, if it is detecting the movement, like how much speed it has gone and so on, then that is categorized as accelerometers. Gyroscopes or sensor, wearable kind of sensor, which provides you the angular rate, like whether it is moving to right or left or that kind of information it has to offer. Global positioning system, this is, you all know, like it has to provide the latitude, longitude of the particular position. Heart rate sensors and pedometer sensors. These are some sensors. Heart rate sensors are most commonly used ones for wearable applications, right? For measuring health of a particular person, especially when they go for jogging, when they go for a particular patient, even not even patient, but a person who go as athlete somewhere, and they also want to check the heart rate, because if it exceeds some particular rate, they have to stop the exercises. So for that purposes, heart rate sensors are also commonly used. Pedometers are used to check the count the number of steps that the particular person has taken. These are all some wearable devices that are used for assisting the uh, person in terms of some applications. So some applications that uses them, right? Actuators, as I have told, in a general sense, an IoT architecture has sensor, actuator, and network. So talking about actuator, it is a component that controls or changes the mechanism of a system, right? It performs actions basically. So some of the examples are like this, like relay switches or solenoid. I have also told in the textiles, it has to switch on the heating, right? In the heating in some the textile, the dress, so that it can support the person who moves in the cold or chilly regions. Yeah, so it has to exert some control signals like electrical, air pressure, and so on. There are several types of actuators too, like hydraulic actuators are available, pneumatic actuators are available, electric actuators are available, thermal, magnetic actuators, as well as mechanical actuators are available. So depending on the action that it performs, right? So typically they are going to do some sort of mechanical action, or it can also be some actions like it is going to enable some signals, electric signals, or some signals that is going to change the information. It is going to change the way how it has to produce something, right? So these are some set of actuators like hydraulic power is utilized to perform action, then it is called a hydraulic actuator. Air is used to perform some changes, then that is called pneumatic actuator. Electric power is used to perform action, then that is called electric actuator. Thermal or magnetic, that is heat or magnet energy is used to change some, do some mechanical action, then that is called thermal or magnetic actuator. There are also actuators where you can also use mechanical energy to create mechanical one. So these are all different types of actuators, right? So so far we have seen the trend of IoT, wearable computing and their applications, several subsets of IoT architecture in general. Now let us go and talk about the serverless IoT architecture, which could play a major role in wearable computing, right? So this is a sort of architecture diagram which explains how serverless could be added. First of all, we all have seen that the wearable devices, they are connected to some edge devices. Okay, edge devices are typically the devices that are very next to or very near to the sensors, right? Most commonly known ones are like our mobile phones, right? Mobile phones are sort of edge devices, right? Of course, an IoT device or IoT application will always have cloud. So a wearable device, if it is sending the information directly to the cloud, it is definitely not good, because no, the information is will have a lot of latency. That is one reason. Second reason would be that the power that it consumes to send the information will be very high, right? So the wearable devices, which are typically low powered ones, will not have that capability to do that, but still they want to get information. Like for example, it wants to do a lot of analysis of the person, or it has to understand the behavior of the person as a whole, right? So the information that it has to process is very high, right? So it cannot always send the information directly to the cloud. Therefore, there is a requirement, there is a dire need of edge devices. For example, the mobile device is required, right? In addition to edge and the cloud, there are also practices to use fog computing. So what is the difference between edge, cloud and fog? You can imagine, like, cloud means, you are seeing like a cloud is very far in a normal analogous form as a normal thing. You can see like a cloud is very far. Likewise, you can imagine like the cloud infrastructure, the compute devices are typically very far, and not only that, it has a large computing capability, right? Capability wise, cloud will have more capability. But fog, you can imagine a normal fog. What is normal fog? Fog, it is typically like something that stays very near to you, right? Likewise, fog computing means the compute devices, typically one small cluster or one very small data center, which will be located very near to the sensory devices or some sensor network. It will be residing very near to sensor network. Why we need such a fog device? Because the computation, especially analyzing some data, instead of sending all data to the cloud, this particular fog can do all these analytics, right? Like you want to judge or predict or evaluate the capability of a person, right? So this kind of information, which can be collected from wearable devices, and all the devices, all the information for every seconds or every 10 seconds are not required, right? You need not do that. So this information can be filtered and it can be processed in the fog, right? Analytics can be done there. Some sort of filtering can be done, even very low level filtering and visualization kind of information, visualization analytics, that kind of information can be done in the edge device itself. Like for example, you want to see how much temperature you have consumed yesterday, day for yesterday, and the previous day. then some sort of visualization is required, some sort of analytics, small analytics is required. That can be done in the edge device itself. Sensors cannot do all these stuffs, right? So therefore, edge devices, fog devices, and cloud devices are definitely playing a major role for your application, IoT application as a whole, right? Let it be wearable device based or any kind of machine to machine communication based applications. For all these applications, serverless definitely will, edge, cloud, and fog will definitely play a major role, right? This is the normal trend. But now we are introducing serverless architecture there, right? What is meant by serverless? So serverless, from the name we can understand, server is not available, right? From the name we may understand like that. But it doesn't mean that the server is not available for computing your application or computing your analytic part, but the server is not readily kept for this particular application. So that means assume that you want to set the characteristics or study the characteristics of a human being, and you have set a lot of wearables on his body, whole body, and the sensor information is sending a lot of information to the cloud. Maybe it is going through some filtering processes of edge and the cloud, fog, and it is reaching cloud and so on. All these things are happening, right? Assume that the information that you collect from the sensors are not done all the time, right? Let us assume like that. Like, you are going to jogging, or you're going for jogging, or you're doing some personal exercise. You will not do personal exercise 24/24, right? All throughout the day. You will not do that. You may do maybe once in a day, or maybe twice. I don't think twice you do, but mostly once in a day. Or you may do per week one day. Some people used to do per week one day, right? Because they are busy with their work, their job and so on. They don't find time to move around or walk around, or they don't do any sort of exercise. And weekly once they may be committed to do that, right? So imagine weekly once, or maybe once in a day, you are initiating the sensors to collect the information. So if you want to run your application without serverless, what would happen is, throughout the day, throughout the year, the whole computing information, computing instance will be live, will be powered on. That means, we all know cloud is a pay-as-you-go model, right? We are hiring the computing infrastructure from a third party, right? Either Amazon is providing, or Google is providing, or the Microsoft is providing them, right? So if they will be happy because you are paying for health check, you are paying such services, and the infrastructure for your application is powered on. That means the VM is activated, and the application is running throughout the day, for the whole week, maybe for the month, for the year. Imagine how much you will you will be paid, right? It will be high, very high, right? So this is a waste actually. This is not useful. So for such kind of applications where sensors are required, or sensory information is triggered for only a very short span of time, then it is better to go for serverless computing environment, right? So the wearable device, maybe you are starting to wear the particular jacket which is having all these pressure sensor, temperature sensor, and so on, and you are going for jogging maybe daily or weekly once, and only at that time the sensory information starts to send the information to the edge device. Now this particular edge device can be configured as a serverless environment, so that only at that time it will try to search the compute device, and it will power on the compute device. Similarly, Only when in the cloud also, the VM, although VMs are there for your application, your VM will not be charged. It is not powered on. Okay. Only when the sensory information goes to the database, it triggers the information, and because of that, it will try to search a new VM, and it will start a new VM, and it will start to run the application. Right? So the data is already there in the storage. So therefore, the data and the state of the application is already there. With the state and the data, it starts to resume the application by searching the new server wherever it finds, and it starts to run from there. So this is called serverless architecture. Thus, functions are executed on these levels at containers on server instances. You are not powered on all the time, and you save energy. You also help infrastructures, AWS infrastructures, to offload the information, the infrastructure to some other people for some other purposes, right? Functions are triggered based on events. So there are certain platforms that are already used, that are available for such activities, like kubeless functions, iron functions, Fission, FN platform. They are all using Kubernetes, and OpenWhisk is from IBM. AWS Lambda, most of you would have heard about Lambda. So this is a serverless function activity that is used by AWS instances. Google Cloud Functions. This is serverless, serverless implementation from Google that works in Google Compute Engine. Then Microsoft Azure has Microsoft Azure Functions to run serverless functions. So wearable computing, the wearable devices are sending information once in a day or once in a week, and that may stay for say 20 minutes or say 15 minutes maybe. Only for that duration, the VM instance or the instance, the cloud instance is triggered, and you will be paid only for that much time, rather than paying for more number of time. So there are several performance concerns also with this particular serverless architecture. The next part, what I would like to show here is the performance issues of such applications, or such serverless applications, right? So like you can see, like mapping issues are there, security concerns are there, memory size problem is also there with serverless functions. Languages, protocols, and standards are another set of issues. Then non-availability of some resources are another issue. There are also terms like cold start, warm start of VM instances. That is, if when it searches for some compute nodes for executing its application, if it has to start from the scratch, if it has to boot the new VM, it has to configure the VM, it has to start the new VM, it has to reserve the memory required for that particular VM, and if it has to start, it will take a lot of time, and therefore it is like cold start. Sometimes the VMs may be powered on and it is already available, and if such things are already available, then you can basically use that, right? So serverless or servers, basically, it is not fully available for you, in the sense, from your perspective, it is available, right? But because why, your application and the state and the data are already there. Okay, so in your as an application developer or an application person who runs or executes this, you will see that like your application is always there, right? Because whenever your data is since the information is has to be processed, has to be analyzed, has to be processed, all these things, you can use this information, right? Because the information, once when it goes to the database, it triggers and immediately it send the state and the data, and it search for the server, available server, and start from there. So as an application person, you always see that the server is available, right? So, but server is not there, right? That is the meaning. That is the concept here. Serverless, right? This means you are not your computation or your application is running on server, but the server is not available for the moment. For the at the before starting, it is not available, right? So once when the data goes, it searches and it finds the server and it start to run from there. Thus, you are providing the say you are saving lot of costs, right? So yeah, mapping issue is there. That means your sensor should perfectly match to the computer resource or whatever resource that readily becomes available, because one day you will be running on VM1, the next day you will be running on VM2, right? Maybe VM1 maybe from some particular location or geographical location, VM2 maybe from some other geographical location. This is possible in cloud, right? Because the configuration and the setting of that particular VM is stored somewhere, and that storage is revoked back, and it is starting from there, right? As like normal VMs, right? So this is possible. So that that mapping sometimes can become a problem, right? Sometimes your state, if it is misconfigured or if it is becoming a problem, then that mapping issue can happen. Otherwise, the non-availability. Sometimes your sensor started to send the information, right? But the network may not be available, or memory may not be available, or container may not be available. Of course, it is not an issue normally nowadays in cloud, but this can happen, right? So that can be another issue. And the cold and warm start I have already discussed. Memory sizes. Serverless normally are fitting to low memory size applications. So that means if you are not, normally we work with free tier instances, right? Cloud instances. So they are offering serverless functions that have like 3008 MB free for functions. So this is just for one function, okay? It is not for the entire application, right? So entire application, sometimes you are going to trigger data like terabytes or something that you can use S3 storage units. But for per function, the memory that you can consume could be 128 MB or 3008 MB. That means the information that comes from the sensor is limited here, right? So such kind of applications will fit properly. Otherwise, you should go for paid ones. Paid ones, of course, Amazon will be very happy, or Google will be very happy to assist you to do that. Similarly, is security and standard issues like lack of proper standards and protocols for serverless functions, or some of the issues. So having said that, serverless is definitely good. Serverless architectures are good for wearable computing and so on. And I have also pointed out that some performance issues are possible. How to trace that, how to monitor that, right? Are there tools that can monitor so that my application could perform well, right? There are some ways, there are some performance monitoring systems and tools also. Here I have listed some set of approaches how to monitor the performance. Okay, typically tracing approach, which means it goes through the log and error messages of serverless functions, which will be stored in Amazon. Okay, so or if you're using Amazon, it will be stored there. Otherwise, Google Cloud Functions also have similar set of logs where you get information of what kind of problems, issues are there. So that tracing approach is like goes through the log and the error messages, and it tries to find out something from out of that. So Sandbox approach is like it prepares a separate sandboxing environment, secure environment, and it tries to run one or two serverless functions there, and it see what will happen, or how impact you or impact it could happen to your application, right? And if the impact is too high, we can go through the sandbox and see what is happening, and we can try to rectify the application accordingly. And then you also have modeling and prediction approach, like you can write a separate model. There are a number of good data analytic approaches for modeling based on the information that you get, the performance information or performance metrics that are collected from ways. No, you can create some models and you can start to predict what will be the performance if your serverless application, serverless based wearable application is running on Amazon. What will happen if it is running on Google Cloud, and so on. Like that, you can also do some sort of modeling prediction approach. Also, there are ways how you can use language instrumentation techniques, like the serverless functions. You can put some instrumented codes, like you can add some functions before and after the serverless functions, so that you get the value, you get the performance values of particular function when it is getting executed. For example, whether it is executing on Oregon, USA cloud, or whether it is running on Tokyo some cloud, right? We want to measure that, we want to monitor that. Then such kind of instrumentation approach will help you to get the values, get the information of relating to that. Also the performance values, like how much time it took to create the VM, how much time it took to create that serverless function, how much time it took to shut down the serverless function and shut down the VM. So accordingly, based on these performance metrics, there are several tools already available for experimenting them. So if having said that you created one wearable IoT application, and you have used serverless function instead of real cloud instances, you have used serverless functions, and now you want to measure, or you want to see what is the performance value, or whether your application, wearable application, is working perfectly or not. For that, there are tools. As I have told, several cloud providers like Amazon, they have their own. Google, they have their own, and Microsoft, they have their own. Likewise, for monitoring also, they have combined. They have offered a few tools, and you can see, like Amazon X-Ray is there, CloudWatch, which is coming from Amazon again, App Dynamics from Microsoft, Google Stack Driver from Google, Application Insights again from Microsoft Tundra. It is a company, separate company, which is offering support for serverless functions. Hexagon is also a company. Wavefront is coming from VMware, and Prometheus, which is kept open for Kubernetes environment, which is almost which is supporting most of the other serverless functions too. So here I have listed some set of performance analysis tools. I have compared these performance analysis tools as like whether they are commercial, whether they are open source, whether they have free trial version, whether they are using log-based approach, like whether they are using logs to do the analysis, whether they are using some sort of plugin, like you can plug in the tool to the application, your wearable application, and you can see what is the performance of that particular application. So whether they are plugin based or whether they are tracing based, like as I have told, in tracing approach, you can the tool will go through the logs and errors of different functions, and it starts to provide the inference, right? And whether they are providing library or whether they are providing agent, whether that tool is enabled as a service, right? So you could see like application insights is a daemon. It is like acting like a daemon which will start priorly, and it will run along with the application. So your Google function, sorry, the serverless function should run, and when it starts running, the daemon will also start to run. So like this, the implementation category of the performance analysis tools are differing. Some are like service, like you can see like the IP address plus port number is enabled for seeing what is happening there. And out of these tools, some tools are more specifically only focusing on functions. Some are focusing on measuring the task as well as application as a whole, right? Like for example, if you see CloudWatch, it is measuring the whole application, whole serverless IoT application as a whole. It will see and it will just give the performance values of the application, right? Whereas if you see Amazon X-Ray, this particular tool will give the insights of individual functions, when the trigger happened and how the trigger happened and so on. So likewise, several tools are helpful, and it will be useful for for serverless functions. So in short, if you see, the performance analysis tools will guide and help application developers to develop the applications. The serverless functions are short-lived, and therefore tools also sometimes suffer. That is one of the research direction that's currently going on. Similarly, the data that it comes out of these performance tools are very high, that you cannot sometimes use normal visualization tools. That becomes another issue. Similarly, the tools, since they are custom to some providers, you yourself cannot develop the tool, right? Or you can develop. I'm not saying you cannot develop. You can develop, but if you develop, you have to use their the provider's infrastructure, and that could lead to vendor lock-in problems. And there are also issues like integration issues, and you as a tool developer, you cannot see the energy consumption. You cannot evaluate the energy consumption of those tools. So these are all some sort of research directions that's happening in the tools spectrum. Of course, as I have pointed out, in this seminar, I think I have made it clear that IoT as a whole, it's very, very useful. The trend is very improving, and it is going on very well. There are lots of possibilities in India for developing newer products and developing things. And the wearable IoT, which comes under the category of consumer IoT, it's becoming more popular because you can develop new self-assistive as well as assistive technologies that help in healthcare sector, industrial sector, and so many sectors together to keep the people productive, right? Keep the people productive. And there are several initiatives from the government as well as several sectors, funding agencies, and so on for developing such kind of applications. And I have then driven you to serverless IoT architecture after explaining the generic IoT architecture. So serverless IoT architecture is definitely useful because otherwise, for any kind of analytics, because any generic IoT architecture will have sensor, actuator, and networked device, where networked device is responsible for doing some analytics, like machine learning, deep learning, whatever you do, you will do it in the networked devices. So instead of holding the cloud instance throughout the day, throughout the week, throughout the year, and pay for all the time that you use, we can go for serverless computing. And I have also pointed out some set of performance issues, especially the warm start and cold start problems are there with serverless computing. And if such performance issues are there, how can you oversee the problem, right? There are some tools also available, and these tools will also help the application developers to develop the entire application, wearable computing application. So with this, I also take an opportunity to once again thank for the organizers and the listeners for patiently listening to the talk. And if any questions are there, please let me know. We from AIC also, we have this incubation centers. We have MSME Incubation Center as well as Atal Innovation Mission Incubation Center for developing newer products. And we are specializing in IoT cloud domain. We have support from several leading universities also from abroad and India, right? So it would be helpful if to you also, if you want to develop some products, you could easily approach me, and I would be happy to support you. Thank you so much.
Thank you, sir, for such an enriching and informative session on serverless IoT architectures for wearable computing, the elucidation on Industry 4.0, consumer IoT, popular wearable applications in healthcare, and architecture for serverless IoT devices was worthwhile to listen, and the futuristic viewpoint in the detailing was the highlight of your presentation. Thank you so much, sir, for the well-versed session. So now it's time for the interactive session. Participants, you can ask your queries by either typing them in the chat box or unmute your mic and ask directly to the speaker. I repeat, you can ask your queries either by typing them in the chat box or unmute your mic and ask directly to the speaker.
Yeah, one question I could see in the chat box.
Yes, sir.
Like serverless in the sense servers are not dedicated, right? Yeah, as I think I have also pointed out the answer, like the user, from the user perspective, the server is always there, okay? Because his application is still running, that's his perspective. But the server is not running. Why it is not running? Because it is stored as a state, and the information, like the data and whatever is required, it is stored in the S3 buckets if it is Amazon, right? So then once again, when the data comes to the particular location, it triggers, the event is triggered, and then it searches for the server. So therefore, as in that perspective, you see it is not dedicated. Okay, but as a user perspective, you can see like it is always there.
Okay, thank you, sir. So
Security of, yeah, another question,
another
sir,
question.
how security of data is maintained in serverless mode? Of course, security is always a problem, normal problem in any kind of cloud setup. But as you could see, compared to the past 5-6 years, now cloud has given a lot of best practices that enrich the security aspects. I think that should not be a big problem. Of course, you can go for some newer security features, so that to enhance your security applications if you are really interested. Otherwise, you go for hybrid approach, where you keep your private data in your private cloud environment, and then you can offload only the not much required data in the cloud.
So we have another question.
Yeah, thus energy efficiency of the network is based on sensors. Energy efficiency of the network, you mean the switches and something like that, or what, or like 5G networking? Of course, energy efficiency is a very important topic to be discussed, right? Because wearable devices, they are purely, mostly battery operated, right? Almost, I don't see the sensors that are, powered along with you, right? They are battery operated, and they sometimes are long lived also. Therefore, the information that you send should be, very precise, small, concise, and therefore energy efficiency should be taken much care, right? And thank you that many people have mentioned that the session is really good. I mean, informative. Thank you so much
So
for
we have another
transmitting.
question.
Yeah, for transmitting
Any
brain
online
signals.
virtual, so
Sorry.
another question,
Uh-huh.
any online virtual tool for IoT simulation?
Um, IoT simulations, there are a couple of simulators, IoT simulators. Unfortunately, I am not working with simulators. I could see, I could I could not therefore comment on that. Of course, Rajkumar Bhaiya from University of Melbourne also has developed one of that simulator, IoT simulator.
Okay, sir.
You
The
could
next
check.
question is
Yeah.
for transmitting brain signals using IoT, what are parameters of IoT module or cloud server need to be considered?
Um, uh, for transmitting brain signals, right? Of course, the devices are becoming nowadays becoming slightly popular, right? So, assuming that you already received that brain signals in the form of electrical information, right? Then comes the IoT part, like you there are some gadgets already available. Gadgets are there that collect that brain signals, and it is capable to provide that information in the form of data, ones and zeros, right? Once when you get that information, then you can start using edge analytics or fog or cloud for processing, especially if the signals that you get has to be processed, like you want to find some the energy level of different portion of the brain. We all know that when we are happy, the effect that it happens no, on the different portions of the brain will be having one particular pattern. When you are angry or when you are depressed, the energy level that gets from that gadget is different, right? So based on that patterns, we want to study that pattern. We want to analyze that pattern. So that should be analyzed in different levels, like edge node, cloud, the fog node, and cloud node, right? Sometimes the all portions of the brain are not required, right? For example, you want to check only the mathematical ability portion, then only that portion needs to be checked. So there are very good projects already available projects. I believe that in the name called Blue Brain, I think, in Europe, it's becoming very popular. They are doing this kind of activity. You could please check it.
Okay, thank you, sir. So I think the queries are over. Participants, I request if you have any more queries, please mail to the speaker. So that was the end of the interactive session. Thank you so much, sir, for clarifying the doubts of the participants. And I thank all the participants too. Now I call upon Chiju S. Ragamalika to propose the vote of thanks on behalf of the coordinators of this online FTP, and I thank its family and all the participants. The speaker, Dr. Shajulin Benedict, who found time despite his busy schedules to concoct an insightful presentation for all of us. Over to you, Chinchu.
Thank you, Chimbi. Good morning. We had an interesting session on serverless IoT architectures for wearable computing by Dr. Shajulin Benedict, Assistant Professor, Indian Institute of Information Technology, Kottayam. So I take this occasion to convey the earnest acknowledgement for our speaker, Dr. Shajulin Benedict, on behalf of all those who are attending this session. Thank you, sir. Thank you so much for giving us such a wonderful session.
Welcome. Thank you for the organizers.
Thank you, sir.